Hi guys, so in this question we're using our logs and our exponents. We're given an exponential equation showing the population of students displaying symptoms can be modelled using the function pt equals ae to the power of bt. We're asked to use the information to show that a is equal to 4 and b is equal to 0.25 correct to 2 decimal places. So we have two unknowns in this equation, that's a and b. So we're going to solve for each separately using the information that we're given in the question. So we're going to solve for a first. To solve for a, we're told that on the first day of study, 4 students were displaying flu symptoms. This means that when t was equal to 0, the population of students was equal to 4. So P0 equals 4. To solve for A, we're going to substitute this information into our equation. PT equals AE to the power of BT. Okay, let's substitute in for what we know. So that gives us 4 equals AE to the power of B all multiplied by 0. So 4 equals AE to the power of 0 because B times 0 gives us 0. In our log rules, we know that anything to the power of 0 equals 1. That means E to the power of 0 equals 1. That leaves us with 4 equals A times 1, so 4 is equal to A. A faster way of doing this question is recognizing that the value in front of your exponent is always the initial value. So when time is 0, A will be your initial value. So we can see here that A is 4. So from here, we're going to solve for B. So again, we're going to write down our equation. PT equals 4E to the power of BT. We're going to use the second set of information to substitute in a value for PT and for T. So we know that when the population is equal to 23, T is equal to 7. That gives us 23 equals 4E B times 7. Let's solve this out. So this leaves us with 5.75 equals E to the power of B times 7, or 7B. So when we're solving for exponents, we always divide out the number in front of the exponent first. That gives us 5.75 equals E to the power of 7B. To solve for an exponent value, we need to convert your exponent into log. So here we're going to multiply both sides by ln. ln is log base e. Multiplying both sides by ln gives us ln 5.75 equals 7b. This is because ln of e is 1. Log base e equals 1. So we're left with ln 5.75 equals 7b. Divide both sides by 7, and we're left with our final answer for B, which gives us 0.25 equals B. Okay, in part B, we're asked to find the number of students who displayed flu-like symptoms after 15 weeks, correct to the nearest whole number. So we're going to use the equation that we just created in part A to find this value. So we're looking for when T is 15, what is the population? Okay, so let's write down our equation. PT equals 4E to the power of 0.25T. Okay, and from here we're going to substitute in 15 wherever we see T and solve for our unknown population. Because this gives us P15, which is the population when the time is 15, equals 4E to the power of 0.25 all times 15. And just substituting our values into our calculator gives us 170 students. So that's correct to the nearest whole number. In part C, we're asked how many weeks did it take for 50 students to display flu symptoms correct to the nearest whole number. So we're asked to find T when the population at a certain time is equal to 50. So again, let's write down our equation. PT equals 4E to the power of 0.25T. Okay, from here, we're just going to substitute in what we know. So we're going to substitute in PT for 50. 50 equals 4e to the power of 0.25t. So we want to solve for our exponent t. So anytime we're solving for an exponent, we're going to change our values into logs. But first, you need to divide out the value in front of your exponent. So you're going to divide both sides by 4. This gives us 12.5 equals e to the power of 0.25 times t. Here, you're going to convert your exponent into a log by multiplying both sides of your equation by ln. This leaves us with ln 12.5 equals 0.25t. This is because ln of e equals 1, log base e equals 1. So here we want to find t, so what we're going to do is divide both sides by 0.25 to find t on its own. So ln of 12.5 divided by 0.25, correct to the nearest whole number, gives us 10 weeks. Okay, in part C, we're asked to draw a graph to show the number of students displaying flu-like symptoms. So in this case, I need to plot my coordinates, where my function is f of x equals 4e to the power of 0.25x. So I'm just substituting out x for t, so I know what to write in my calculator. So I substitute this function into my calculator, and I find the coordinates between 0 and 5. Plot your points, and then freehand draw a line between them, and this will give you your graph.